My name is Chuck Fresh from Computer Care, and I wanted to give you an introduction to coding. Now, if you want to learn how to code, I don't care how old you are, if you're like 100 years old like me, or if you're young, a kid just starting out, there are some great ways to learn how to code and some really bad ways to learn how to code. Believe me, I've done both of them. What you don't want to do is get stuck in this classroom and learn these lines of code for like weeks. And it comes out with this little line of black text says, "Hello world." No, that's not what you want to do. We lose so many talented, potentially talented programmers that way because they're not given the right education. So what this is using the program called Scratch, the platform called Scratch, completely free. It's made by geniuses, rocket scientists at MIT, and they've provided this platform for free. Check it out. I've got links below some of the stuff I've done personally. This is part one of a two-part video. I found that my videos are too long, so I'm going to cut it into half. I'm going to give you the introduction, which explains the platform, how it works, some basics, and then part two is we'll get into it and we'll actually create some really cool stuff. So enjoy, have fun. And I did for sure. I love this stuff, and it'll give you hours of fun and enjoyment. Thanks for watching. Oh, please like, comment, and subscribe. Thank you. Hey now, Chuck Fresh, welcome to Scratch. What is Scratch? It's a visual program tool made by the great people at MIT. And what it does is it allows you to actually code with a drag and drop interface using blocks instead of those long, crazy words that I'll show you in a minute here. So it's amazing what you can do, and I'll show you some of the stuff other people have already done in this platform. It'll just blow your mind, the possibilities, the potential, and some of the other features too, which allow you to share and build upon other people's stuff without having to ask anybody. I mean, it's just a really cool community-based programming tool that teaches you more logic and the possibilities of what you can do as a coder. So if it's your first time coding, man, that is no problem at all, because you really don't need to know anything. If you can drag and drop, you're golden. You're ready to go. This lesson is a basic overview of Scratch for beginners. If you know a whole bunch of Python or any of the other programming languages, no big deal. It doesn't matter. This is completely different. Now, if you've done Scratch for a while and you've created these beautiful Scratch programs, yeah, you might find this a little bit boring. But if you've never done anything before, no problem. We're going to walk you through. That's what this is from scratch, as if you'd never looked at it before. No coding experience is needed. I don't care if you've never put a line of code or anything, you've never drag or drop, you've never done Minecraft or Roblox or anything at all. We don't care, because you don't need any experience for this, and that is part of the beauty of this platform. Not much math is needed. I'm not going to lie. I mean, there's a little bit of math required here. Most of the math that you will see is, because computers do most of the calculations for you. However, the location of the items on the screen that are in your program will take a little bit of knowledge of an X and Y axis. So it's not complicated. It's basically, it goes across and up and down, and you just need to know coordinates. You need to put an X coordinate and a Y coordinate in there. And again, if you don't know that, you can just copy it right off the screen. It does all the calculations for you. So it's no big deal if you don't know how to do it, but it is a little helpful. But you don't need much math at all. I mean, you don't have to be a math genius to use Scratch. No crazy hardware needed, man. I've seen people run this thing on an iPad. Of course, it runs better on a PC or a Mac, but most of the legwork, most of the stuff is done on the server. Most of the hard, heavy computing is done on the server level. So you need a pretty good internet connection? Yeah, probably, but most home internet connections should be more than adequate. Programs are instantly compiled, and that's beauty. I mean, it's compiled right away, rather than having to, like when you write a program with a lot of traditional programming languages, you have to wait for the program to compile into a language that your computer understands. Well, the beauty of this thing is it's already done for you on the back, like on the fly, like instantly it's compiled. And that's the beauty. This stuff is already written in a language the computer can understand. And basically they've done all the heavy lifting for you. And beautiful, Scratch is completely free. I can't believe it. So who is Chuck Fresh? Who am I? I'm a former database administrator and HTML programmer. I've built some, actually at the beginning of the web, when we first started doing e-commerce sites, I was one of the guys who built a pretty big website for a pretty big company that you may have heard of. And I'd rather not share it. I don't like to brag. I'm a former network engineer. I was putting together networks many moons ago, and also troubleshooting, repairing them. And I also owned a computer repair store. I was a computer technician for several years too. I am a current computer science and ESL teacher. I am a former famous DJ. As a matter of fact, once in a while, you'll see me hitting up the wheels of steel, but not too often anymore. Professional radio announcer. You've heard my voice somewhere on the radio or in television. I do a lot of that stuff still. I'm a semi-famous YouTuber. Got a lot of subscribers, so hey, thank you if you subscribe to any of my channels. I'm a writer, actor, director, producer, and I'm a dad. So pretty broad level of experience. Basically, I can talk to anyone. So that's kind of where that goes. A bunch of other stuff, too, I won't mention, but it's all good stuff, though. So coding is awesome, ladies and gentlemen, and you should learn it. You absolutely should learn it. It's probably one of the last few growing industries you can get yourself into, other than fast food. But there's not a lot of money in fast food, people, unless you own the restaurant. But coding can provide you with a very, very good living for the foreseeable future until computers learn how to code themselves. And that, I'm not going to lie to you, is in the pipeline. Believe me, they're trying to figure out how to do that now. But they'll always need troubleshooters, and coders will be around for the foreseeable future. You should definitely learn it. It's a great career path. But when we attempt to teach kids coding in school, probably, and I'm guessing at these numbers, there's probably somewhere between 60 to 70% of them drop out, like within the first couple of lessons. And I'll tell you why. Here's why. We lose a lot of good people who would otherwise be really good at coding. This is some sample Python code. Yeah, take a look at that. It's confusing, right? Basically, it's a very simple program. It's not hard to do. But it's just, you put a kid in a classroom and you teach him all these commands at first, which essentially do a whole lot of nothing, really. I mean, that's unfair, but I mean, you do all this code, you spend a week, 2 weeks, and it crashes on you and it doesn't work. It never works the first time. Nothing ever works the first time. It's very rare, but it just rarely works the first time. So you're doing all this stuff and you're driving yourself crazy. And then you call your friend over, hey man, look what I just wrote, this really cool program. Look what it does. And your bro's like, oh my God, you just wrote a program over 2 weeks that plays tic-tac-toe? And your friend's less than impressed. And you're not getting the feedback you deserve because honestly, if you wrote a working tic-tac-toe game with all the logic and it's displaying correctly and actually running, that's a huge achievement for any beginner programmer, for any programmer, period, even an experienced programmer. But this is where we lose a lot of kids. They get bored. They're like, wow, I did all this code, man. I spent weeks on this stuff and this is all I got. So there's got to be a better way to show people the potential of coding. I mean, even adults. I mean, I'm an adult and I learned some real coding back in the day. I was originally a computer science major. I work with punch cards, okay? That's how far back I go. And then the Scratch thing comes along. And I see this for the first time. I'm like, oh my God, this is the answer. I actually had an idea of doing something like this, but thanks to the folks at MIT, they already did it. So these are some of the things you will see on the Scratch platform. I want you to go to Scratch and explore it. The links are in the comments below. And take a look at some of these people are doing. Kids and adults have wrote these amazing compilations and programs. They're not going to be as graphically beautiful as the originals or, you know, I mean, they're not, I mean, you're fairly limited what you can do as far as processing power but it's got tremendous flexibility, but you're going to have to be a little bit more creative because these really weren't intended to do things like this, but people have found workarounds and ways to do this. And the beauty of this is you can look at these programs, look inside at the code that other people wrote, copy it over to your own profile, and then change it and reverse engineer it and make the mistakes 1,000 times. And it costs you nothing except time. Endless Harry Potter games. If you're a Harry Potter person, you're going to love this. I mean, there's trivia, there's, they call them platform games, just probably thousands of Harry Potter-based games, mostly trivia, I think. And this one is insane. It's actually a Minecraft clone. And just looking at this screen, it's just so well done. And when you play it, it's actually like you're playing a version of Minecraft. There's Minecraft platformers, but this one actually is like you're playing like a low-end version of Minecraft, and it's insane how good some of this stuff is and how creative they are. There's even a Fortnite clone, which it's kind of clunky. It's nowhere near the you can see the trees there. They're not really well done, but just the fact that somebody could come close and create something that kind of reminds you of Fortnite is just mind-blowing that you can do this. And this was my capstone project. And this is something I've always wanted to do. And it took me, I'm not going to lie, it took me about a month to get this right. And there's still bugs in it too. And I invite you to figure it out too. I'll share the link for this too. It's one of them old school flipboards you used to see at airports and in some different businesses like many years ago. But I just thought it was really cool. So this is what I created. And man, this was a headache and a half. There's stuff I've never done before. But I got it done, and it works. It's functional. It's really cool. It's neat. And I'll see, you can see what I've done, too. I'll show you a couple of my projects. So what can you do with Scratch? Well, you can create new projects from scratch. Having never coded before, it is possible for you to write, and via a drag and drop interface, you can actually write something like within a half hour and actually get some code working on your screen. So it's like an instant gratification, like, oh, wow. So I didn't have to spend a week writing this tic-tac-toe in Python. Now I can actually drag and drop a bunch of stuff on my screen and actually see the results within a shorter amount of time. And that is pretty darn cool. Again, I told you before, we can copy other people's projects, which is allowed. You're entirely allowed to do that as part of the user agreement. So you can copy it over to your platform and then change it and learn from them. How did they do this? How did they make this Minecraft game? Well, you can dig into it. You can take some pieces out, see if it still works. You can reverse engineer it, troubleshoot it, change it, make it your own. And yeah, copy other people's projects and change them. You could put your face on some of those objects if you want to, and now it's your game. It's your custom game that nobody else in the world has. So that is completely allowed in Scratch, because you can't sell them. So nobody's really making any money at this. So copyrights are essentially invalid in this particular platform, for the most part anyway. And just don't go crazy. You can play games and run programs that others have created to see exactly what is possible on this limited platform. And then once you get into the real coding, then you can kind of expand upon that and get into the real world. So what do you need? Well, if you want to save things, you are going to want a Scratch account. And I think it's a really good idea, because if you start working on something and you don't have an account, which you totally can, you can work anonymously, you can't save it. So if you want to go back and then pick up where you left off, if you don't have a Scratch account, you got to start all over again. Not awful, but some of those projects, you may get kind of in depth and are like, wow, I'll never be able to do that again. Of course you will, but it's a lot easier if you already have an account. You'll need a valid email address, either mom, dad, your own email address, and they'll just send you a confirmation, and that's how you log in if you have an account. But again, you don't need one. You're going to need a PC, Mac, or an iPad. PCs or Mac work best. And most importantly, time. It's summer, and there's a pandemic in 2020, man. What else you got? Time. You're sitting around at home in summertime. This is a great time sitting your home and just build some games, man. It's awesome. So what are we going to learn today in this little lesson? Well, we're going to learn the basics of Scratch. Just the basics. Again, this is a beginner level, as if you've never seen it before. And we're just going to walk through some of the basics here. We're going to create a little program, and then you can actually do it on your own after the class. And I'll share mine with you too, in case you want to look at it and reverse engineer it, change it, and if you need hints. Logic of programming architecture. And this is probably the key takeaway from any programming course. You need to know how all these parts of a computer program work together to achieve whatever you're trying to achieve. We'll talk about that in a second. Debugging and troubleshooting. Man, you're going to do a lot of that. There's going to be something you're going to do. You're going to drag something somewhere, put something somewhere, leave something out. And you're going to say, darn it, this thing doesn't work. I did everything right, but there's always something wrong. And debugging and troubleshooting is a great way to learn how to program, because usually when you discover those mistakes, you never make it again. And it makes you a better programmer. And rebooting you. There's going to be times where you're going to become super frustrated and you're just going to need to walk away. So you're going to need to I call it rebooting yourself. You Control Alt Delete your brain. Just walk away, go get some orange juice, take a walk, play some basketball, play some Xbox or PlayStation, and then come back an hour later next day and look at it with a fresh set of eyes. So We're going to learn a little multimedia integration. We're not going to do any heavy stuff because a lot of this is a little more involved, and I don't know if you can hear over this platform. But I'll show you where the stuff is and how to do it. And collaboration with others. You're going to learn how to use other people's stuff in your projects, and other people use your stuff in their projects. And collaboration is a very important tool in the business world. So what is coding? I've got to give people a couple of definitions. They get mad if I don't give it to them. So basically, coding is telling a computer what you want it to do. That's what it is. In a language or a logical sequence of steps that the computer can handle in a way the computer can understand. Because the computer can't yet understand me talking to it. I can't walk up to a computer and say, "Computer, I want you to create a beautiful video game and put me in it and a lot of beautiful cars." Because the computer can't yet do that. I know we've got Siri and we've got Google and all these voice recognition things, but they're not yet smart enough to take all that information that you can tell them and create something based on your oral or spoken words. So it has to be a logical sequence of steps, and I do cover that in a different lesson. And because if you don't do it logically, then the computer's going to get confused and it's not going to know what to do. It's like, all right, well, I did this step, but I did it before I should have done it, and now it's useless. I mean, think about it. I learned from one of the people I learned from is putting together a peanut butter and jelly sandwich. Like, you need bread and peanut butter, and you got to put it together. But if you put the bread together and you put the peanut butter on top of it, or you never open the jar of peanut butter, there's a lot of strange things that need to happen in a sequential order for the thing to work. Otherwise, you have a program or a sandwich that is just not going to do anybody any good. And you got to do it in the way the computer can understand, in a language that the computer can understand, or some sort of input. And yes, using human input. That's either your keystrokes, or you dragging or dropping, or you typing in the manual code. And it all leads to a desired output. Develop a game for me, something that I can play and have fun with and share with my friends. So that's basically what coding is. I have a whole video on the history of computers and coding that talks about that in different languages and the history and how we got to where we are on my YouTube channel. It's very, very interesting. So watch it if you get a chance, if you haven't. This is the basic Scratch window if you've never seen it before. I know a lot of you have. You're going to see there's a bunch of pieces to this window here. You're going to see like all the functions on the left, and then you're going to see what we call blocks, which actually tell your stuff to do stuff. And then you're going to see this preview window and sprites and backdrops and some other coordinates here, your X and Y coordinates that we talked about, size, direction, blah, 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 blah. So we'll cover all that stuff in this basic introduction. So here's your code. This is where you grab your blocks of code. Now, somebody at MIT created the physical code for all this. There's a whole bunch of lines of that crazy Python-looking code. I don't know what language they use. I think it's a unique language. But this is where the code exists, and they call them code blocks, or blocks of code in the Scratch platform. So this is where you're going to find all that stuff on the left-hand side. And again, these are blocks, and these are the actual commands. And again, each one of these blocks has a whole bunch of lines of code behind it somewhere that people already wrote for you, and they made these nice little chunks called blocks. And you can just drag and drop them, which is beautiful. And then there's block categories. And we'll talk a little bit about those right now, block categories. So each one of these categories does something a little bit different. They're kind of color-coded. Some people find it helpful, some people don't. I still get confused once in a while. So what does motion do? Obviously, motion is how you make things move, how you make things walk, how you go from X to Y, or one point on the X-axis to another point on the X-axis, how you get things to move across or up and down the screen. That's motion. How you can turn things. You can twist them around and bounce them off the sides. All that stuff is under the motion category. And then looks. You can change colors, effects, transparency. You can hide something. You can show something. You can change the size even. There's so many options under looks. Looks is basically how your sprite or character looks. And we'll talk about that, what a sprite is in a second. Sound. We can play sounds or music. This is the multimedia thing we're talking about. We'll drag a couple sounds in here too to show you how this works. Events. This triggers when things happen. You don't want everything to happen all at once. If you're playing like a game or telling a story, you don't want everything to happen just like everything thrown at you because it doesn't make any sense. It's not logical progression. So you need sometimes events to determine exactly when something should happen. And control. These are functions for programs or loops. A little more confusing, but you'll understand here when we go through it. Sensing. We're not going to cover too much on sensing today, but these are triggers based on input or location. You can have things follow your mouse. If one thing touches another thing, then it can do something. Like if a ball hits a wall or something, that will trigger a certain function, and this is where you find that under sensing. Operators, this is where your math stuff is. Your math functions, greater than, less than, equal, add, subtract, multiply, divide, all that fun stuff. And also, this is where you're going to find the randomness. And randomness is important in really any game, because you don't want things to be predictable. You want it to be random, although there's no such thing as random. I do a whole class on randomness too. We'll talk about that some other time, but we won't do that today. But randomness is really cool, and you need it, and it's under operator, so you know where it is. Variables. So this is a little more advanced if you're storing numbers, lists, or strings of things like trivia games or names or scores and stuff. You're going to find this under variables and lists. That's just where it's stored. And my blocks. A little more advanced, but once you get really good, you'll be able to create your own custom functions using blocks. So you don't have to rebuild these functions every time you want to use something. You make something really cool. Oh, I want to do this again. Maybe I could use this in another game. You could throw it under my blocks, and that's where you would find that or place that or store that. So those are the block categories. Now there's additional things underneath. There's a little button there, and you can access these extensions. Some of them used to be part of the categories, but they're no longer there. There's music where you can actually write your own songs. It's got a huge amount of instruments and drum beats, and you can actually create music in Scratch, which is really cool. You create the next hit song. I don't know. It's got a pen function, which is helpful if you want to draw things on the screen. Some games require that you draw unique things on the screen, and that's where you find that. You can add these extensions to your block categories. Video sensing. You can do cool things with your video camera. One of the projects one of my students worked in last is when he saw a face or something on the video camera, it did something in the program, and I thought that was pretty neat. Text to speech. You can make your projects talk. I love this one. You'll see this in a bunch of my own games and creations. You can actually, it's a robotic voice, but it's really cool. You can type stuff in and have the computer talk. Translate. Yeah, go into different languages. And makey, if you're into that thing, you can make anything into a key. And there's Microbit, Mindstorms, Lego Boost, Education, Go Direct Force and Acceleration, all kinds of other cool plugins that you need some additional stuff with. But it all interfaces nicely with the Scratch platform, and that's beautiful. So this, we're looking at the stage, and the stage is the box to the upper right-hand corner with the cat in it. His name is Scratchy Cat. But that's the stage. That's where you're going to be able to preview everything that's going to show up in your program as you are developing it. So this is the stage up here in the upper right. You can make it small or bigger if you want more stuff underneath it. If you're dealing with a bunch of sprites, you can adjust it. Those little buttons up top. You can also full screen it too. Sprites. What are sprites? Sprites are basically the characters that will be in your games. They could be buttons, they could be people, they could be animals, any kind of objects that you assign code to are called sprites. They're pretty important. You have to have, I think, at least one in your program. Well, let's look at the stage here. Here I've applied a background, and as we told you before about those coordinates, you have X, which goes left and right, and you have Y, which goes up and down. And Scratchy Cat right now is located at coordinate X is positive 16, Y negative 126. That's just where Scratchy Cat is. I guess it's the middle of him. I'm not sure where it measures that from. But this is your Scratch stage, and this is kind of where you tell your stuff where they should be in your game, and that's going to be kind of important. So your X-axis, this is kind of geometry, left to right. You've got negative 240 to positive 240 in increments of 1. So you can be as precise as you want to be, but the window isn't real big, so you're probably going to count by tens for the most part. The y-axis down to up goes from negative 180 to positive 180. So it's more of a rectangle than a square. So keep that in mind that it's wider than it is taller. Center is obviously 0, 0. Your x-coordinate 0, y is 0. And everything changes from that center point there. You see that gray dot in the middle. That's the center. The location is defined as the exact coordinates. Again, Scratchy Cat is x16, y negative 126. So you may want to tell your ball, your wall, your people, your actors, any of your sprites where to be at a certain point in time, maybe a starting point more than anything, because things can move. Green flag, you see in the upper left-hand corner here, means go or run. And the red flag or the red stop sign is stop. That means you stop doing whatever you're doing right now. And let me dig in here and figure out what I did wrong for the most part. So sprites, these are, again, the characters, the objects that you are going to assign code to. You can have, man, I think some of them I've seen with 20 to 30. I don't know if there's a limit on the amount of sprites you can have, but I don't think it matters. I don't think you'd ever need that many, but I'm sure some people have had some ridiculous numbers of sprites in here. So you do need sprites to attach code to. Each sprite has its own individual code, and each sprite has something called costumes, which we'll talk about too. They don't all have costumes. You can make costumes. Some of them have predefined costume, which is nice. And you can choose one of the many, many, many sprites that come with Scratch. This is just some of them, one of the pages here, and they're sorted up top. You can search for them, but you can see animals, people, fantasy, dance, music, sports, food, fashion, letters, or you can draw your own or upload your own. You can upload a picture of your face if you want to. They don't care. Throw it in there as long as it's in a JPG or a PNG format. You can upload your own sprite and attach code to it. So what about Sprite? A Sprite can be an animal, person, button, or just about any object. A ball or a jet fighter or a robot, anything that you want, anything you can create or anything you can find in the Scratch Sprite library. You can use, again, one of theirs. You can modify theirs. You can create one from scratch. If you're an artist, it's great. You can do that. Or you can upload your own sprites, which is cool. Sprite can be moving or stationary. So the sprite can just stay there in the middle. Things can go around it. One of them can move. The other ones can be stationary. It's really up to you and what the objective of your program is. So yeah, it can be moving or stationary. They don't care. Yes, you can have multiple sprites. Again, I don't know what the total number is, but we talk about resources, which we'll talk about in the future class. If you start getting too many sprites in there, it's going to start dragging, be real slow. You can resize your sprites. You can go from, well, you can hide them. You can go from invisible to like 1% all the way up to, I think, a couple 100%. You can make it bigger than the sprite actually is. But remember, you've got a limited space in that window to work with, so be cognizant of the size of your sprites. And again, your sprite can be visible or invisible. You can turn it on or off. There's maybe some reasons that you want a sprite to be invisible because it's there and you don't want to delete it because it has a function in your program, in your overall game or whatever you're doing, but you just don't want people to see it at that particular moment. So you can do visible or invisible, and we'll look at that too. Some sprites, again, have costumes, which is an animation. Animation is like a different pose, like how you make cartoons. There's different poses. Their legs might be in different places, their eyes, their mouth, something that makes it look cartoonish. You can actually create cartoons, and people have done this in Scratch using costumes and sprites. You can change color, positioning, all kinds of stuff. It's pretty fluid and pretty flexible. And you do need at least one sprite to assign your code to. You can make it invisible if you want to. I tried to do it once on the background. It didn't work out so well. So I think I was telling a story or something with backgrounds. It was a slideshow, and I couldn't do anything because I didn't have a sprite. So I put a sprite in there, made him invisible, and I was ready to rock and roll. So more advanced stuff. Again, the costumes, we'll play with a little bit of that today. Backdrops, which are the backgrounds, which you can change. You can use multiple backdrops, which make it look really cool, like playgrounds or beach scenes or space or basically whatever you want. Sounds, you can use, they've got a tremendous library of sounds built into Scratch already that you can use freely. And you can upload your own too. People upload their favorite songs to it. The backpack, and you can take stuff. This is more advanced stuff. We're not going to cover a lot of this today, but if you create this like really cool code, like I made an explosion for something, And it was a real pain in the butt to do. It was a lot of steps, a lot of lines, a lot of blocks of code. And I was able to drag that in my backpack so I can use that in other projects. So you can port things from one project to another project, which is really cool. And then there's the extensions. We talked about the music, text-to-speech, Lego, and all that stuff too. So the question is, are you itching to scratch? Are you ready to take a look at this monster? Let's dig in and see what we can do.